Right now, at this precise moment, something extraordinary has just unfolded. After weeks of unexplained silence, after mounting pressure from the scientific community and growing public speculation, NASA and the European Space Agency have finally released the official high-resolution images from the Mars flyby of 3I Atlas. And I must tell you, as someone who has spent 5 decades studying theoretical physics, these images have fundamentally shaken my understanding of what we thought was possible. Because what we're seeing in these photographs doesn't just challenge our assumptions about comets or interstellar objects, it challenges our very definition of what constitutes natural versus artificial phenomena in our universe. The images arrived yesterday, October 24th, without fanfare, without press conferences, uploaded quietly to NASA's planetary data system in the late evening hours. Within minutes, amateur astronomers and professional researchers worldwide began downloading the files, and what they discovered has sent shockwaves through the global scientific community. The Mars Reconnaissance Orbiter's high-rise camera, the most powerful telescopic instrument we've positioned beyond Earth, captured 3I Atlas during its closest approach on October 3rd from a distance of just 29 million kilometers. That resolution reveals details smaller than a football field, and those details are unlike anything we've encountered before. Let me walk you through what makes these images so profoundly disturbing. When we photograph conventional comets approaching the Sun, we expect certain predictable features. A bright central nucleus composed of ice and rock, a fuzzy coma surrounding it, formed from sublimating gases, perhaps dust jets streaming outward from active regions heated by solar radiation. These are the hallmarks of natural cometary behavior, patterns we've observed thousands of times throughout astronomical history. 3I Atlas displays none of these expected characteristics. Instead, the high-rise images reveal something that looks almost manufactured in its precision. The primary structure appears geometrically regular in a way that natural objects simply should not exhibit. Where we expected irregular potato-shaped morphology typical of asteroids and comet nuclei, we're observing smooth surfaces interrupted by what can only be described as distinct features. 3 separate protrusions extend from the main body at nearly perfect 120-degree intervals, creating a tripod configuration that defies random formation through accretion or impact processes. Each protrusion measures approximately 2 kilometers in length, tapering toward the ends with mathematical precision. But here's where the analysis becomes truly unsettling. Spectroscopic data overlaid on these images reveals that those 3 protrusions are not composed of the same material as the central body. The main structure shows albedo characteristics consistent with carbon-rich compounds, absorbing most incident sunlight and appearing dark against the background of space. Yet those 3 extended features, they're highly reflective, almost mirror-like in their surface properties. They're bouncing back solar radiation with an efficiency that exceeds 90%, comparable to polished metal or precisely engineered solar panels. Dr. Sarah Chen at MIT's Kavli Institute performed a detailed photometric analysis that was published just this morning. Her conclusions are stark and unavoidable. The reflectivity pattern, she writes, is inconsistent with any known natural mineral composition. The surface appears optically smooth at wavelengths down to 200 nanometers, suggesting manufacturing precision rather than natural crystallization.